start the pump on debubble. Make sure that the isolation valve is open and the cap is off. Also make sure that you override the actuator manually and that it is open on full flow. This allows for air movement and water movement around so that debubbling can take place. Leave this to operate until the two green lines on the pump go into the center mode and flash continuously. This takes approximately 10 minutes to operate. If you find that you are low on water, top up. You can start PC Tools at the same time while this operation and make sure that you have connection via your ZTH EU. Please note that you will get that it is disabled and that you get zip master, transmit and receive, and you'll be seeing a pulse signal. Please be aware, like normal on PC Tools, that it may change the COM line that it's utilising. Check service setup. Make sure that it has already been set to run at 0.5 to 10 volt on the Y characteristics. Again, it will advise you that you have up to 21 litres a minute. As can be seen, like all EP and MF actuators and devices, it also gives the serial number, again, that corresponds to what it's communicating to, with that on the actual device itself. Once bubble has taken place, as you can see, you get the two green dot flashing lights. You can now turn the pump to its maximum . You want to turn it clockwise. You need to make sure that the cap is therefore reconnected and that the valve as can be seen, the valve is now been changed to closed and the cap is tightly screwed down. As you can see, you've got anything at your full speed of 2 watts. In simulation, now changed to set point tool. This will now allow you to change to a setting of 8 litres a minute. You can operate this at 21 litres a minute as a maximum value. That is a good starting point, and that you now want to change the motor into automatic movement. You can see the motor is now driving, and also you can actually see that you're getting a percentage of flow As can be seen, the valve is still motoring to its close and then open position. As can be seen, you only get, even with the pump at full flow, it doesn't quite reach the 21 litres a minute. Now to show the change, adjust set point to 8 litres a minute. As will be seen, this will motor. You can now click on the trend record and remove maximum position. That's not needed, therefore giving you a set point, actual flow and valve percentage movement. You will hear that the actuator is actually motoring very slowly and pulsing to its required position. As can be seen now by the graph, it is now stabilised. Once stabilised, you can show by turning the valve and pump speed down to a reduced amount of flow. Do it in quarter segments. Again, you'll see straight away on the graph that it's dipped on its flow because we suddenly reduced the speed of the pump. This will now allow the valve to increase to bring back the required flow rate. You can now repeat this process with the pump and turn it down to half its volume. Again, you will see an immediate response. Again, you could do a large movement by knocking it all the way down and showing the graph has quite a big dip because of the reduced actual flow, and that you can see the actuator responding by ramping up quicker, again illustrated on the graph. This therefore illustrates cost saving and efficiency savings where a pump can be reduced and ramped all the way down when not requiring full flow.